more of what we've already done. We are going to talk about that unit circle again. We've looked at it once, but that was last week. So we're going to talk about this a little bit more. We know when I talk about a unit circle, that's a circle with a radius of what? In a unit circle, the radius is just 1. So this is a special circle that we're looking at. The radius is 1. If you think about the S equals R theta that we've just been dealing with, if the radius is 1, that means in this particular circle, S and theta would have the same measure. So, in other words, like this angle right here is the same as this arc length out here. What we want to do today is take this circle and we are going to put all of our information on it. Up to this point, we have done the angles and the radians. We are going to add ordered pairs as well today. So I gave you a nice big copy of the unit circle. This is the one that will have everything. So if you like to color code things, you probably want 4 colors here. If you need to borrow color pens or something, I can give you some. You don't have to. But we know how to do half of it already. So when we talk about degrees, this is 0 degrees, or what's the other option for what you can label it as? 360 degrees. Doesn't matter which one, they're the same. Make sure though, we're putting a degree symbol. And then what are these going to represent? Those are the angles from our hand. And we know if we jot down here, a straight line is 180 degrees. And then how do we get these? Those are just your reference angles. So if I do 180 minus 30, 180 minus 45, 180 minus 6. Because reference angles always go from the x-axis, so we have to use that 180 and not the 90. Then in the third quadrant, those are bigger than 180, so you add your reference angle. So 180 plus 30, 180 plus 45, 180 plus 60, and this down here would represent 270. Right? In the fourth quadrant, we always subtract from 360. So 360 minus 30, 360 minus 45, and 360 minus 6. Notice, quick check to make sure you've done it right. Your angles increase as you go around the circle. So you'll know if you flipped a couple of them because it wouldn't be increasing as you go around. So does everyone feel confident that they could take a blank circle and put the degree measures in there? Okay. Next, we did the radian measures. So we said 0 degrees is the same as 0 radians, or 360 degrees is the same as 2 pi. So whether you say 0 or 2 pi, those are the same.
Hey, you're on the sprint today, aren't you?
Yeah. All right. Then, we know in the first quadrant, remember our pattern was always something pi over a number. Remember, it's just 1 pi. And what happened to those numbers as you went around? They got smaller. 30 degrees is the same as pi over 45 is pi over 60 is pi over 90 is pi over 2. 6, 4, 3, 2. Those numbers are getting smaller on the denominator. Now, worst case scenario, if you forgot that 30 degrees was pi over 6, how could you figure it out? Yeah, that's how we got it originally. We just converted. So you could take 30 degrees times pi over 180 like we were doing on our quiz when we had to convert those. Okay, 180 degrees is the same as pi. That's why we multiply by pi over 180. Those things are equivalent. Now, the nice thing about these, all of them will always have a pi. And the denominators will match the reference angle. So this was my reference angle of 30, which is the denominator 6. This was my reference angle of 45, which is over 4. Reference angle of 120 or of 60, which is over 3. You guys?
So how'd you get to 3, 4, 6? Just from the other side?
Yep. So like this one was over 6, so all of these reference angles will be over 6. Alright, does anyone remember what the pattern is? One less, because it's like doing pi minus that. So 1 less than 6 would be 5. 1 less than 4 is 3. 1 less than 3 is 2. Again, worst case scenario, if you forgot, could you do 150 times pi over 180 and get it? Absolutely. But if you recognize these patterns, you can fill it out pretty quickly. So we know in the third quadrant, it's still the same. It'll be pi over, and my denominators will still be 6, 4, 3, 2. Then the numerator, it's bigger than pi. It's bigger than 180. So what's the top? 1 bigger than the bottom. So 1 more than 6 is 7. 1 more than 4 is 5. 1 more than 3 is 4. 1 more than 2 is 3. So 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2. In the fourth, we still have the pi over our denominators. So my denominators are 6, 4, and 3 again. To get these, we're subtracting from 2 pi. So what was the pattern that we saw? Double minus 1. So 6 times 2 is 12, minus 1 is 11. 4 times 2 is 8, minus 1 is 7. 3 times 2 is 6, minus 1 is 5. So that's the part we had done before. Do you guys think you could do that on your own? If I just gave you a blank circle one day and said fill this out, could you do that part? The last thing we are going to add to this is ordered pairs. Now, these ordered pairs are not just arbitrary numbers we're placing here. Okay, if you truly took a circle with a radius of 1 and plotted it on an XY axis, these would be the true ordered pairs that show up at each of these points. Now what we know, if you think back to our trig functions, what was the definition of sine in the very first chapter? Using x, y, and r. Sine was, and cosine was, but in the unit circle, what's r? 1. So that means sine is y, and cosine is x. So we are going to add ordered pairs to this. And when I look at these ordered pairs, the x value is your cosine, and the y value is the value of sine. So, for instance, some of these ordered pairs we can do pretty easily. If this is 0, 0, what would this point be? The radius of the circle is 1, so the x would be 1, and what would be the y?
0.
Okay, think about your hand trick. When we do 0 degrees, if you fold in your thumb, cosine is the square root of the bottom over 2, radical 4 over 2, which is 1. Sine is the top, radical 0 over 2, which is 0. So that matches my hand trick. All right, let's think about 30 degrees. So if you do the hand trick, 30 degrees, your x is cosine. So that's the square root of the bottom over 2, which is radical 3 over 2. Sine of 30 degrees. So it'd be radical 1 over 2, or 1/2. Do you guys see how these ordered pairs relate to that hand trick? It's the same as the values we've already been using. We're just writing them as ordered pairs.
I'm lost.
Okay. Yeah. So at pi over 4, or 45 degrees, you do the hand trick. So cosine is the square root of the bottom over 2, so that would be square root of 2 over 2. Sine of 45 degrees is square root of 2 over 2. At 60 degrees, what is the value of cosine? 1/2. And the value of sine? At 90, what is the value of cosine? 0. What's the value of sine? 1. Which, if you think about on the unit circle, if you start here, you don't move left or right at all, so your x is 0, your y is 1. Is this making sense so far? Okay. Let's talk about 180. So if I were right here, what would this ordered pair be? Your x is -1, we don't move up or down at all, so y is 0. So we know that cosine of 180 is -1, the sine of 180 is 0. Now, we know, we've talked about doing quadrants and reference angles a lot. So I know at 150, sine and cosine are the same as at 30, but the only difference is could be positive or negative, right? Think about graphing points in Algebra 1, Algebra 2, college algebra. If you're in the second quadrant, what's negative, x or y? X. So it will be the same ordered pairs that we had here, except the x is negative. So my first point would be negative radical 3 over 2, positive 1/2, which makes sense. The sign is positive in quadrant 2. Okay, so this would be negative radical 2 over 2, positive radical 2 over 2. Negative 1/2, positive radical 3 over 2. If you are in the third quadrant, what's true about x and y? They're both negative. So it's these same 3 ordered pairs, but everything's negative. So at 270, can you tell me what this point would be on the unit circle? All right. In the fourth quadrant, what's true? You think about graphing these, the y value is negative. So So cosine is positive, sine is negative. So same points, but the y is negative. So what we see is when we're dealing with these reference angles, everything with a reference angle of 30 has the same ordered pair, except different things are negative depending on the quadrant. When your reference angle is 45, okay, the same ordered pair, you just have to watch your sign. When your reference angle is 60, same ordered pair, the only difference is the positive and negative. Do you guys see these patterns? So this is just another tool for helping us. So from now on, some of you like filling out that table. There'll probably be people in here that will want to fill out a blank unit circle on every test. Okay, that's an option. I have plenty of copies, so anytime you want one, I can give you one. If you know the patterns, it will get to the point where you can fill one out really, really quickly. We'll probably start doing some of these as quizzes every now and then, just kind of make sure we're all getting that. But the benefit of this, if I now said, find the sine of 3 pi over 2, I could look at my circle, is sine x or y? So I can go to 3 pi over 2, y is negative 1, so sine of 3 pi over 2 is negative 1. If I said cosine of 5 pi over 4, you can look at 5 pi over 4, cosine is x, so it's negative radical 2 over 2. If I wanted cosecant, what would you have to do? Yeah, you flip sine, so you flip your y. If I want to use these to get tangent, how could I do that? You can do the finger trick still. That still works. We also know tangent is sine over cosine, or y divided by x. So you could actually divide these. So if I said find the tangent of 7 pi over 6, then tangent is y over x. So I could do negative 1/2 divided by negative radical 3 over 2. And to divide fractions, you flip and multiply. So I get 1 over radical 3 or radical 3 over 3. This is not different than what we have done. Okay, this is just another tool. So we've been listing quadrant and reference angle and using our hand trick. That still works. This is just another option where you can fill out this whole circle and read the circle to help answer them. Okay? Any questions for me, Chris? Alright, so let's just practice. So if I asked for the exact values of each of these, I would like for us to think through these and use the circle as a resource to help. I don't want you to rely on it too much. You have to be able to fill out one on your own before it's going to benefit you on the test. So on tests, I'm happy to provide you with a blank one, but I'm not going to give you one filled out. So you have to know how to get to that point. All right, so sine the 3 pi over 2. So if you go to 3 pi over 2, is sine the x or the y? The y. What's the y value at 3 pi over 2? Negative 1. We look at our circle. Okay. Cosine is your x. So what's the x at 3 pi over 2? 0. Tangent. You can think of that as sine over cosine, or y divided by x. So that's negative 1 divided by 0, which is undefined. Can't have 0 on the bottom. Let's just use the circle. Let's see if we can think through this and then just use the circle to check ourselves. So we had questions like this on our quiz yesterday, and we had them on our previous test when it was just in degree form. If I give you a negative, what do you need to do? And I told you if you're doing that on a calculator, you just leave off the pi's. You do negative 5 over 3 plus 2. So that would give you pi over 3. So if I'm just thinking about that, pi over 3 is in what quadrant? The first. Okay. Pi over 3 is like what angle? 60. So if you wanted to do your hand trick, tangent of 60, square root of the top over square root of the bottom, radical 3 over radical 1 is radical 3.
I'll just add in 2 pi, make that just 1 pi.
So 2 is like 6 over 3. So negative 5 plus 6 is a 1 over 3, and then you stick the pi back on. If you want to use your circle to check that, okay, we would be at pi over 3. Tangent is y over x, so radical 3 over 2 divided by 1/2. So you can flip and multiply, and you get radical 3. So we can do it from the hand trick, we can do it from the circle. We're going to get the same answer. Just another tool for figuring these out. So if I said cosine of 2 pi over 3, so we could just look at our circle. Let's try to think through it and use the circle to check. What quadrant is 2 pi over 3 in? Reference angle, I told you on these, you just ignore the number on top, so it's just pi over 3, which is like 60 degrees. So in quadrant 2, is cosine positive or negative?
Negative.
What's the cosine of 60? 1/2. If we wanted to use the circle, we go to 2 pi over 3, cosine is the x, and it's negative 1/2. So, same answer. Are we okay with those? You guys understand how to use the circle to double check?
Wait, what is tangent x over y?
Y over x, or sine over cosine. So I want to talk about if I give you one that isn't nice, we might need to use our calculators on some of these. We've used calculators before. When I say 1.85, is that degrees or radians? Radians. So we need to switch the mode on our calculator. Now you will have to go back and forth, so we'll have to change our mode frequently. So you hit mode, and you want to make sure it's in radians. And then you should just be able to type in cosine of 1.85. So I want everybody to try that and make sure you get the same thing. Should be negative 0.2756. For B, let's not do cosine, let's do cosecant. So we're in radian. How would I do cosecant? 1 divided by sine. So we get 2.0307. Are we okay with doing those? Everybody got those answers? Let's do this example. want to find S, which if we're talking about a unit circle, S and theta are the same thing, in the interval 0 to pi over 2. What does that tell me if you're between 0 and pi over 2? If cosine of S is equal to 0.9685. Do we know when cosine equals 0.9685? No, so we have to do our calculator. You guys remember, if you want to get the cosine to the other side, what do you have to type in? The inverse. That cosine to the -1, second cosine. Your calculator will give you the answer in quadrant 1, so you don't have to do anything special since we're in the first quadrant. And we get 0.2517. I know that I'm in radian mode because 0 and pi over 2 are radians. If I'd said in the interval 0 to 90, then what would you need to do on your calculator? Put it in degree mode. Okay, so that interval tells me which mode I need to be in. So far, so good? What if I said this? Find the angle in the interval pi to 3 pi over 2 if tangent of S is equal to 1. All right, if I am between pi and 3 pi over 2, what quadrant is that? Can you tell me the reference angle? When does tangent equal 1? Think about your handshake. 45 degrees. Or if you're looking at your unit circle, tangent is 1 when x and y are the same thing. So we're looking at 45 degrees, which is pi over 4. So pi over 4 in quadrant 3. We know in quadrant 3 the numerator is 1 higher. So that would be 5 pi over 4. We could have just looked at the circle to help with that as well. We're in quadrant 3. If tangent, y divided by x, is the same, or is 1, then we're looking for when x and y are the same value. And we can see that's right here at 5 pi over 4. Is that okay? All right, so I want to stop. I'm done for today. I'm going to give you guys time to work. Okay, 2 through 34 even, and 52 through 68